Welcome to the deep dive. Today we're tackling something huge, but maybe mostly invisible. It's this pervasive challenge that's, well, everywhere. We're talking about plastic, but probably not in the way you usually think about it, like, the big stuff, the bottles and bags you see. No, we're going much deeper into what some are calling a true invisible pandemic. It's plastic that has seeped into, well, pretty much every part of our lives. Medicine, food packaging,
Yeah.
you name it. And while that big plastic pollution crisis is obvious, the real stealth threat, according to the research we've looked at, is microscopic. Just picture this. Tiny bits of plastic, smaller than a grain of sand, totally invisible. They've been found way up high on Mount Everest.
Yeah, absolutely astonishing.
And down in the deepest part of the ocean, the Mariana Trench.
Crushing depth, unbelievable.
In Arctic ice, deserts near the equator. And here's the kicker. It's in the air we're breathing right now.
Mm-hmm.
The water we drink, the food we eat, it's not just out there. It's right here. It's potentially inside us.
And that pervasiveness, that's exactly why we need this deep dive. Our mission today is really to get under the skin of this phenomenon. We need to unpack what these microthreats actually are, where they're coming from, how they travel so far, how they're impacting the environment, our health, and just how big this challenge really is. What really jumps out from all the sources is just how everywhere this problem is. It's hitting places you think are totally pristine. It's not just a local issue near cities or factories. It's global, a silent infiltration, really, and we need to understand it better.
Okay, yeah, that makes sense. Clarity is key here, isn't it? Because plastic is such a broad term. It's easy to think of, like a water bottle. But microscopic bits everywhere, that's different. So let's get down to basics. What exactly are microplastics? Because it sounds like it's not just one specific thing, right?
That's a really critical point. We absolutely need to be precise. So the official definition, the one used widely by scientists, comes from NOAA, that's the U.S. National Oceanic and Atmospheric Administration. They define a microplastic as any plastic particle that's 5 millimeters in diameter or smaller.
5 millimeters. Okay, like a sesame seed, roughly.
Exactly. Or maybe a small lentil. That's the upper size limit. But, and this is crucial, the lower limit is much less defined. It goes way, way down into the nanometer range. We're talking particles so incredibly tiny you can't see them without very powerful microscopes.
Nanometers. Wow. So even smaller than micro.
Much smaller. In fact, the sources often talk about particles smaller than 1 micrometer, that's 1,000 nanometers, as a separate category. Nanoplastics. And these nanoplastics, well, they're potentially even more worrying.
Why is that? What makes them more dangerous?
It comes down to that incredibly small size. Nanoplastics can do something most microplastics can't. They can actually get through biological barriers. Think about cell membranes, or even the blood-brain barrier, which is designed to protect our brains.
Whoa.
Yeah. So these nanoparticles can potentially enter directly into the tissues, the organs, maybe even individual cells of living things, us included.
So it's not just passing through your gut, it's getting inside.
Potentially, yes.
Yeah.
That's the concern. They could bypass our body's defenses in ways larger particles might not.
Yeah.
And that completely changes how we need to think about the health risks.
Okay, that's a big deal. And you said microplastic isn't just one material.
Right. It's not like it's all just broken down water bottles. It's an umbrella term. It covers a huge range of different plastic types, different polymers. You've got polyethylene, PE, think plastic bags, bottles. Polypropylene, PP in containers, car parts. PVC, polyvinyl chloride pipes, window frames. Polystyrene, PS foam cups, insulation. PET, polyethylene terephthalate, that's very common for drink bottles. And honestly, many, many others.
Okay, so many different kinds.
And each one has its own chemistry, its own additives mixed in during production. They break down differently. They might leach different chemicals.
Which raises a huge question, doesn't it? If it's so diverse, this massive mix of tiny plastic bits, how on earth do you even start to track it all?
That's one of the biggest challenges. There's no single test, no single solution. It's incredibly complex.
Right. Okay, so complexity is the name of the game here. And these tiny bits, they don't all start the same way, do they? The sources mention 2 main origins.
That's correct. Understanding the origin is absolutely fundamental if we want to tackle this problem at the source. The standard way scientists categorize them is based on how they got into the environment in the first place. You have primary microplastics and secondary microplastics.
Primary and secondary. Okay, let's break this down. What are primary microplastics?
So primary microplastics are particles that were actually manufactured to be small. They didn't break off something bigger. They started out microscopic. They were often designed for a specific purpose in a product and entered the environment directly in that tiny form.
Manufactured small. Like, on purpose.
Yeah.
Give us some examples. What kind of products are we talking about? Some of these were quite surprising when I read about them.
Yeah, some are definitely surprising. The most well-known example probably are microbeads.
Ah, right. The face scrubs and toothpaste.
Exactly. Tiny plastic spheres, often polyethylene. They were intentionally added to tons of cosmetic products, facial scrubs, body washes, even toothpaste for that gritty, exfoliating feeling. The problem was, once you use them, they just washed straight down the drain.
And the water treatment plants couldn't catch them.
For the most part, no, they were too small. They sailed right through the filters and ended up in rivers, lakes, and oceans.
So we were basically pouring tiny plastic beads directly into the water.
Pretty much, yeah. Now, thankfully, many countries have banned them and rinse-off cosmetics. The U.S. did in 2015. But the ones already out there, they're still circulating. Their legacy, as the sources say, will be felt for a long, long time.
Okay, so microbeads are one. What else falls into this primary category?
Another huge one, particularly from an industrial perspective, is industrial pellets. You might hear them called nurdles.
Nurdles, like little plastic seeds.
Kind of, yeah. They're small, lentil-sized pellets. They are the raw material used to make almost all plastic products. Billions of them are shipped around the world.
So how do they get into the environment?
Spills. During transport loading, unloading ships, trucks, and during processing at factories, little spills happen constantly, all over the world. And these nurdles are now, believe it or not, one of the most common types of pollution found on beaches globally. Go look closely at the tide line sometime.
Wow. The building blocks of plastic just loose on the beach.
Exactly. It shows leaks all through the supply chain. And then there's a third big one, synthetic fibers.
From clothes, like fleece jackets and sportswear.
Precisely. Polyester, nylon, acrylic, spandex, all those synthetic fabrics. Every single time you wash them, they shed thousands, maybe even millions of tiny fibers.
Just from washing.
Just from washing. And just like microbeads, these fibers are tiny. They slip right through washing machine filters, through wastewater treatment plants, and straight into our rivers and oceans. Our laundry is actually a major source of microplastic pollution in water.
That's kind of mind-blowing. So a lot of these primary sources were almost, like you said, designed small enough to escape our filters.
In many cases, yes, whether intentionally or just as a consequence of their size and use.
Okay, that covers primary. But you said there's another category, secondary microplastics, and that this one is actually bigger by volume?
Yes, significantly bigger. Secondary microplastics are the fragments that result from the breakdown of larger plastic items. Any plastic out there, a bag, a bottle, a fishing net, car parts, anything eventually gets broken down by environmental forces into smaller and smaller pieces.
So the plastic litter we see becomes the microplastic we don't see.
Exactly. It's a transformation process, and it happens through a few key mechanisms.
Like what? How does a big plastic bottle turn into microscopic dust?
Well, a major one is photodegradation. Sunlight, specifically the UV radiation in sunlight, attacks the chemical bonds in the plastic polymers. It doesn't just fade the color, it makes the plastic brittle, weak, it starts to crack and fragment. Think of an old plastic chair left outside, it gets crumbly, right?
Yeah, definitely. It just falls apart.
That's photodegradation. Then you have mechanical wear, physical forces, waves smashing plastic on rocks, wind blowing sand against it, abrasion.
Okay, like physical grinding.
Exactly. And a huge example here is car tires. Tires contain synthetic rubber, which is a polymer. As they wear down on the road, they shed enormous amounts of tiny particles.
I never really thought of tires as plastic pollution before.
It's a massive source, actually. Those particles wash off roads into drains, rivers, or become airborne. And there's also some biodegradation, where microbes try to break plastic down. But for most plastics, this is incredibly slow, like centuries slow. It doesn't really solve the problem.
So, sunlight, physical wear, slow breakdown. What are the main sources then? What big items are creating the most secondary microplastics?
It's pretty much anything plastic that gets into the environment. Single-use items are huge culprits. Plastic bottles, bags, packaging. Just the sheer volume is enormous. Then you have lost or discarded fishing nets and gear, ghost gear, which floats around breaking down for decades. Fragments from building materials like pipes or insulation, car tires, as we mentioned. Even paint particles.
Paint, like house paint.
House paint, paint on ships, road markings. A lot of paints contain plastic polymers. As they weather and flake off, they contribute microplastic particles.
Wow. It really is coming from everywhere. So the plastic we see is just the tip of the iceberg, slowly turning into this invisible flood.
That's a very good way to put it. The visible pollution is bad enough, but it's constantly feeding this much larger hidden problem.
And once these tiny fragments are created, primary or secondary, they don't just sit there, do they? You mentioned earlier they travel globally. How does that happen? How do they get from, say, a river in Europe to the Arctic ice?
It comes back to their size and weight. They're incredibly small, often very light, low density. This means they can be easily picked up and carried. Wind can carry them huge distances through the atmosphere. Rivers act like conveyor belts, flushing them from land out into the sea. And once they're in the ocean, they get caught up in the massive ocean currents that circulate around the entire globe.
So they just ride the currents.
Exactly. And this is why we find them literally everywhere. It explains the Everest discovery, the Mariana Trench findings. Their physical properties make them incredible travelers.
Okay, let's talk about the oceans then. You said rivers carry them there. What happens once they reach the sea? Do they just float around?
Oceans are definitely the main sink, the final destination for a huge amount of this plastic. Millions of tons flow in from rivers every year. Once there, yeah, they get swept into the global current systems. You might have heard of ocean gyres.
Like the Great Pacific Garbage Patch.
Precisely. These are huge, rotating current systems, and they tend to concentrate floating debris in certain areas. But that name, garbage patch, is a bit misleading. It's not usually a solid island of trash you can see for miles.
Right, you said it's more like a soup.
Exactly. Our sources describe it as a soup, where the concentration of plastic fragments, especially microplastics, is incredibly high, often invisible from a boat, but densely packed.
But not all plastic floats, right?
Correct. Some polymers are naturally denser than water and sink. Others might float initially, but then tiny organisms, algae, bacteria, start growing on them. This biofilm adds weight, changes their buoyancy, and eventually makes them sink. It's called biofouling.
So plastic pollution isn't just on the surface.
Not at all. It's throughout the water column and heavily concentrated on the seabed. That's why they've found microplastics in the Mariana Trench over 10 kilometers down. It's contaminating these unique deep-sea ecosystems that we barely understand.
And what about the really remote places, like the poles? How does it get there?
Both ocean currents and atmospheric transport play a role. Currents carry floating and suspended plastics northward and southward, and wind carries tiny particles through the air, where they can fall with snow or rain onto the ice sheets. So microplastics get transported to the Arctic and Antarctic, and then trapped in the ice.
Trapped in the ice. Wow.
Yeah, and there's a really worrying implication there. As that ice melts due to climate change.
It releases all that trapped plastic back into the ocean.
Exactly. It's like a ticking time bomb. A preserved pollutant being released, adding yet another stressor to those vulnerable polar environments.
That's deeply concerning. Okay, so the oceans are a massive soup and sink. But it's not just the oceans. What about rivers and lakes? You said they're transport arteries, but are they polluted themselves?
Oh, absolutely. Rivers and lakes serve that dual role. They're definitely polluted ecosystems in their own right. And yes, they are the main channels carrying microplastics from land-based sources out to sea.
Where does the pollution in rivers and lakes come from?
Multiple sources. Urban wastewater is a big one. Remember those fibers from laundry, microbeads that weren't banned, industrial discharges, runoff from roads carrying tire particles and other debris, and runoff from agricultural fields too.
Agricultural fields. How does plastic get there?
We'll get to land contamination in a moment, but yes, agriculture is a source. So all this stuff funnels into rivers and lakes. Studies show high concentrations in places like the Great Lakes in North America, Lake Baikal in Siberia, and major rivers everywhere. The Rhine, the Danube in Europe, the Yangtze in China, the Ganges in India. These vital freshwater sources are heavily contaminated.
Which obviously impacts the water we might drink or use for farming.
Directly. And the ecosystems within those rivers and lakes.
Okay, so let's talk about that land contamination. It's maybe less talked about than ocean plastic.
It is less studied, yeah, but the scale is potentially enormous. Some research suggests there might be even more microplastic contamination in soils than in the oceans.
Really?
Well, think about agriculture. One major pathway is using sewage sludge, the solids left over from wastewater treatment, as fertilizer.
Okay.
That sludge contains all the microplastics that made it through the treatment plant, fibers, fragments, etc. Spreading it on fields puts plastic directly into the soil.
So we're fertilizing with plastic.
Inadvertently, yes, in many places. Another big agricultural source is plastic mulch.
Those sheets of plastic they lay over fields.
Exactly. They're used to control weeds, retain moisture, but over time, under the sun and farm equipment, they degrade, tear, and leave fragments all through the soil.
Okay, that makes sense. Soil contamination. What else?
Atmospheric deposition.
Yeah.
We touched on this plastic rain.
Right, particles carried by wind.
Yes. They get lifted into the air, travel potentially thousands of kilometers, and then fall back down with rain or snow, or just as dry dust. This contaminates soils, forests, even remote mountain ranges far from obvious pollution sources.
So it's literally raining plastic onto the land. That must mean it's in the air we breathe too, right? If it's falling out of the atmosphere.
Absolutely. Microplastics are now recognized as an invisible component of the atmosphere itself, which means, inevitably, we inhale them.
Constantly. Like just breathing normally.
Yes. Indoors and outdoors, the sources are varied. Wear and tear on synthetic fabrics is a big one. Household dust is often dominated by microfibers from clothes, carpets, furniture.
So house dust isn't just skin cells and pollen anymore.
No, it's got a significant plastic fiber component. Then there's tire abrasion again. Those particles become airborne. Wind can also lift particles from contaminated surfaces, like dried sewage sludge applied to land or landfills.
No, the air itself is carrying plastic.
It is. And the implication, as the sources state, is pretty stark. No corner of the planet could be considered completely free of this. If it's in the air, it's everywhere.
This global spread is just staggering. Highest mountains, deepest trenches, oceans, rivers, land, the air. It's a truly pervasive issue. So let's shift gears now. What does all this mean for life? For ecosystems, for animals, and ultimately for us? The sources talk about physical and chemical impacts. Let's start with the physical harm.
Right. And the research paints a pretty grim picture here. The consequences for wildlife are, frankly, devastating. It's affecting organisms right across the food chain.
How does the physical harm manifest? Is it just animals eating plastic?
Ingestion is the most direct physical impact, yes. Countless marine and freshwater animals, from the absolute smallest, like zooplankton.
The base of the food web.
Exactly. All the way up to huge whales that filter feed. They consume these particles, either mistaking them for food. Tiny plastic bits can look like fish eggs or small prey, or just incidentally swallowing them while feeding.
Okay, so they eat it. What happens then? Does it just pass through?
Sometimes, maybe. But often, no. The plastic can accumulate in their digestive tract. It builds up. This can create a false feeling of fullness. The animal feels like it's eaten, so it stops feeding properly.
But it's getting no nutrition.
Precisely. Leading to starvation, malnutrition, lack of energy, and eventually death. Plus, many plastic fragments have sharp edges or are rigid. They can physically damage the animal's insides, cause internal injuries, ulcers, inflammation, blockages. It's incredibly harmful.
Like swallowing tiny knives almost.
It can be, yes. And then there's a really critical process called biomagnification.
Biomagnification, that sounds familiar. That's when toxins build up the food chain.
Exactly. But it applies to the plastic particles themselves too, and the toxins they carry, which we'll get to. So tiny organisms like plankton eat microplastics. Maybe they don't excrete them effectively. Then a small fish eats lots of those plankton.
So the fish gets a bigger dose of plastic.
Right. And then a larger fish, or a seal or a seabird, eats lots of those smaller fish. The concentration of plastic increases at each step up the food chain.
So top predators end up with the most plastic.
Potentially, yes. They accumulate the plastic burden from everything lower down. Seabirds are a particularly tragic example mentioned in the sources. They often mistake floating plastic bits. Bright colors attract them for food. And worse, they feed this plastic to their chicks.
Oh, no.
Yeah. The chicks' stomachs fill up with indigestible plastic, they can't take in real food, and they starve. Scientists find dead albatross chicks with stomachs packed full of things like bottle caps, lighters, plastic fragments. It's truly heartbreaking evidence.
That image, yeah, it's awful, just devastating. But you mentioned the physical damage is only part of it. There's this chemical threat, too, the Trojan horse idea.
Yes, the Trojan horse analogy is perfect. Microplastics aren't just inert physical objects. They act as carriers for hazardous chemicals, making them potentially far more dangerous.
What does that work? Are the chemicals in the plastic itself?
That's one part of it, yes. Intrinsic toxic components. Remember how we said plastics have additives? Chemicals added during manufacturing to give them specific properties, flexibility, flame resistance, stability.
Like phthalates and BPA.
Exactly. Yeah, phthalates, bisphenol A, BPA, flame retardants. Many of these additives are known to be toxic in their own right. Some are carcinogens, others are endocrine disruptors, meaning they mess with hormone systems, which can affect development, reproduction,
Well,
metabolism.
and these chemicals can come out of the plastic once it's ingested.
Yes, they can slowly leach out from the plastic particles into the organism's tissues. So the animal gets a continuous, low-level exposure to these toxins.
Okay, so chemicals in the plastic. What else makes it a Trojan horse?
The other, perhaps even more significant aspect is their ability to pick up other pollutants from the environment.
Like sponges.
Exactly like sponges. Microplastics floating in the water have a large surface area relative to their volume, and their surfaces tend to attract certain types of chemicals, especially oily, water-repelling ones. They absorb and concentrate persistent organic pollutants, POPs, from the surrounding water. We're talking really nasty stuff. Pesticides like DDT, industrial chemicals like PCBs, heavy metals like mercury and lead.
So the plastic soaks up these poisons?
Yes, and concentrates them to incredibly high levels. One source mentioned the concentration of toxins on a microplastic particle can be millions of times higher than in the water around it.
Millions of times.
So when an animal swallows that particle, it's not just getting plastic, it's getting a highly concentrated dose of poison delivered right into its gut, much more than it would get just from the water itself.
That's incredibly insidious. A tiny toxic bomb.
It is. And there's even a third layer to this Trojan horse effect.
Yeah.
Pathogens.
Disease carriers?
Potentially, yes. The surface of microplastics provides a great place for microbes to live and grow. Bacteria, viruses, algae, they form communities called biofilms on the plastic. Scientists even call this the plastosphere, a whole new artificial ecosystem.
Right.
And some of these colonizing microbes can be pathogenic, like the bacteria that causes cholera, Vibrio, or they might carry antibiotic resistance genes.
So the plastic could help spread diseases.
That's the concern. As these plastic particles travel long distances on currents, they could transport harmful microbes or invasive species to new areas, posing new ecological risks and potentially new health risks.
So physical blockage and injury, leaching toxic additives, concentrating environmental poisons, and carrying diseases. That's quite a cocktail of harm.
It really is a multifaceted threat, far more complex than just pieces of plastic floating around.
And ultimately, with it being in our air, water, and food chain, this comes back to us, doesn't it? It's not just an animal problem.
No, inevitably, humans are exposed through multiple pathways. Inhalation, drinking contaminated water, eating seafood that has ingested plastic. The potential impacts on human health are a major area of ongoing research and concern.
Okay, we've covered what they are, where they come from, how they travel, and the devastating consequences. It paints a challenging picture deeply woven into our modern world.
It absolutely does. Our reliance on plastic has created this boundary-crossing, ecosystem-spanning problem. From the deepest sea trenches to the air we're breathing right now, its influence is profound.
So thinking about the future, navigating this age of plastic, here's something to really chew on. Given how everywhere these microplastics are and how incredibly long they last, what fundamental changes do we need in how we think about materials, how we consume, how we manage waste? What's needed to actually turn the tide on this invisible pandemic for ourselves and for the planet?
That's the critical question, isn't it? It demands rethinking our entire relationship with plastic, from production to disposal, and finding truly sustainable alternatives and systems. It requires action on every level, from individual choices to global cooperation.
Now just take a second and think about your day so far. You've probably touched, used, maybe even looked at dozens of things made of plastic, right? It's everywhere. Packaging, clothes, cars, our homes. I mean, it's just completely woven into modern life. But here's a thought. What if that plastic isn't just around us anymore? What if it's actually inside us? Today, we're diving deep into something mostly invisible, but incredibly pervasive. Microplastics. We're not talking big chunks of waste here. We mean tiny, tiny particles, some microscopic, some even smaller nano size that are, well, pretty much everywhere now. And that leads us to the core question for this deep dive. If these things are all over the planet, are they definitely inside us? And what does that even mean? Our main guide for this is a really comprehensive source called Microplastics in Our Bodies on Our Planet. It lays out how this hidden contaminant has, well, kind of taken over. So our mission today is simple. Extract the crucial takeaways.
How do microplastics get into our bodies? What happens once they're there? And importantly, what on earth can we actually do about it? From global policy down to, the choices you make every single day. Because this isn't some abstract environmental thing anymore. This is directly relevant to you, to your health, and honestly to the future.
That really hits the nail on the head. It's quite something, isn't it? For years, this idea of plastic actually getting inside our bodies, it felt like maybe a bit theoretical, a distant worry. But the key insight here, the real shift, is that it's not a what-if scenario any longer. Not at all. Recent science, like the research compiled in our source, has just slammed that door shut. It unequivocally confirms it. Microplastics are inside us.
Wow. So it's moved from assumption to fact.
Exactly. That leap fundamentally changes the game. It means this isn't just an environmental issue, it's a public health issue,
Yeah.
a serious one. And the scope, how widespread and intimate it is, it's probably far beyond what most people imagine. It's touching our actual biology.
Okay, so let's trace that journey then. Where do these tiny invaders actually come from and how they make their way into us? I guess the most obvious way would be food and drink.
Absolutely, you've got it. The primary pathway, the main route in, is oral. Through our mouths, with the food we eat and the beverages we drink. The source confirms their presence in food and drink pretty much worldwide. So this isn't a localized problem, it's global. It affects basically everyone, regardless of diet or where you live.
It's that widespread.
It really is. It's a direct consumption pathway, and it's actually much harder to avoid than you might think, precisely because these particles are just so common in the environment where our food and water come from. Take water, for example. Fundamental, right? We all drink it.
Of course.
Well, here's something that surprises a lot of people. Microplastics are found in both bottled and tap water globally. But concentrations in bottled water are often significantly higher.
Really? Higher and bottled. You'd think it would be cleaner.
You would, wouldn't you? But the research points pretty strongly to the bottles themselves, especially PET bottles, that's polyethylene terephthalate. They seem to shed particles over time during storage, transport, and it's not just the bottle material. The actual bottling process, washing the bottles, filling them, can introduce airborne microplastics and fibers right into the water before it's even sealed.
Huh. So the container itself is part of the problem.
In many cases, yes, it's a real aha moment for many people, makes you rethink that supposedly safer choice.
Okay, so water is one source. What about food? You mentioned seafood earlier.
Yes, seafood is a big one, particularly for people who eat it regularly. Think about filter feeders, oysters, mussels, clams. They filter huge volumes of water to feed.
And they suck up the microplastics along with the food.
Precisely. They accumulate them from the surrounding water, so when we eat them, we're essentially eating those concentrated microplastics. But it's not just shellfish. Our source also highlights smaller fish, like sardines or anchovies, maybe shrimp too, things that are often eaten whole.
Including their digestive systems.
Exactly. So whatever plastic they've ingested from their environment, well, we ingest it too when we eat them. It paints a really clear picture of how the marine food chain becomes a direct pipeline for microplastics straight to our plates.
That's not a pleasant image.
Yeah.
Are there other foods, things you wouldn't expect?
Oh, definitely. And this is where it gets even more pervasive. The source points to everyday staples, things you'd think are completely natural, far removed from plastic, like sea salt.
Sea salt. How?
Well, often from the seawater it's harvested from, if that water contains microplastics. Then there's beer.
Beer?
Yep. Could be the water used for brewing. Maybe even tiny fragments from plastic components used in the brewing equipment itself. Honey, too.
Honey. How on earth does plastic get into honey?
Airborne particles. Microplastics floating in the air can settle on flowers, or bees might pick them up inadvertently while foraging, and even sugar, potentially from processing equipment or, again, airborne particles in the processing plants. So, you could be adding a sprinkle of microplastics to your morning coffee or salting your dinner without having the faintest idea.
Wow.
It really forces you to think about how deeply ingrained this is in our food system. Popping up in places you just never suspect makes it incredibly hard to avoid completely.
Okay, so diet is clearly a major pathway. Our plates, our glasses, almost unavoidable, it sounds like. That's definitely food for thought, literally. But you mentioned airborne particles getting into honey. That brings up the next point. It's not just what we consume, is it? We're breathing constantly. What about the air?
Exactly right. Inhalation is another huge pathway, and you could argue it's even less avoidable than what we eat or drink. We can't just stop breathing, can we?
Not recommended, no.
We are constantly, passively inhaling microfibers and tiny plastic fragments floating in the air all around us. And interestingly, this seems to be particularly pronounced indoors. Studies often show higher concentrations inside buildings than outside.
Higher indoors. Why is that?
Often down to things like poorer ventilation, plus the sheer amount of synthetic materials we surround ourselves with indoors. Think about your home, your office, shops, cars, places where most of us spend the vast majority of our time.
So what kind of indoor things are we talking about?
Our source specifically calls out carpets, upholstery, curtains, anything made with synthetic textiles, polyester, nylon, acrylic common materials in clothes, furniture, furnishings.
So just walking on the carpet or sitting on the sofa can release these.
Potentially, yes. Every little abrasion, every bit of friction can shed tiny fibers. Even just wearing synthetic clothes sheds fibers. And think about laundry washing synthetic garments releases millions of microfibers into the air and, crucially, into the wastewater system.
Right, I've heard about that with fleece jackets and things.
Exactly. And once these particles are inhaled, they don't necessarily just get breathed out again. They can travel deep into the lungs and settle there. That's a direct impact on our respiratory system. Some scientists even think larger inhaled particles might get trapped in mucus than swallowed, which adds to the amount we ingest orally, too.
So even in our own homes, supposedly clean environments, we're breathing this stuff in.
Pretty much constantly, it shows just how deep this problem goes, right into the most basic act of breathing.
Okay, ingestion, inhalation. What about our skin? It's our biggest organ, our barrier to the outside world. We slather creams, lotions, cosmetics on it every day. Can microplastics get through that way too? Feels like the last defense.
That's a really interesting question, and the dermal route through the skin is definitely less studied than eating or breathing it in. But yes, it's an area where concern is growing. Our skin is generally a pretty good barrier, especially against larger particles. But the source points to the potential for nanoplastics.
Nano, so even smaller than micro.
Much smaller. We're talking billionths of a meter. And the concern is that these incredibly tiny particles, especially if they're present in some cosmetic products, might be able to penetrate that skin barrier.
Oh.
Well, many cosmetics, exfoliants, foundations, sunscreens, lotions can contain plastics. Things like polyethylene beads for scrubbing, or plastic polymers to form films or act as thickeners. Polypropylene, nylon, they show up in ingredient lists.
So they're intentionally added sometimes.
Sometimes, yes, for texture or function. Now, if these are applied, especially if the skin barrier is maybe a bit compromised, like a small cut or very dry skin, or if the particles are nano-sized, there's a theoretical risk they could slip past the main defenses. They might potentially enter through tiny openings like hair follicles or sweat glands. Now, the actual extent of absorption, how much gets through and what happens then? That's still being actively researched. We don't have all the answers yet, but it definitely raises a question for you, the listener, about the products you put on your skin every day. What unseen ingredients might be in there, potentially making their way into your system? It's a less obvious pathway, but one that definitely needs more investigation.
Right. This is where it gets really, really interesting and maybe a bit unsettling. For a long time, I think there was this sort of comforting idea, maybe, that most of what we took in, whether we ate it or breathed it, would just kind of pass through, cause minimal fuss and then out the other end, like a what goes in must come out sort of view. But that's just not the whole story anymore, is it? Feels like a major shift in understanding.
You're absolutely right. That optimistic view, that comforting idea that it all just passes through, well, it's been pretty decisively and I'd say alarmingly refuted by recent science. And this really is a monumental shift in how we understand this problem. It ramps up the urgency considerably.
Because it means it's not just passing through.
Exactly. It's not just transient. We now have solid empirical evidence showing these particles are doing much more than just taking a quick trip through our system. They are settling in tissues, they're migrating around the body, and in some cases, they seem to be becoming almost integrated into our biology.
Okay, so where's the evidence? Where have they actually been found in the human body?
Well, the most obvious place, confirming consumption, is in human feces. That confirms the oral route we talked about. They go in, some comes out. That's the primary way they leave the body.
Right, that makes sense.
But that's really just the starting point. They've also been found embedded directly in human lung tissue.
In the tissue itself, not just passing through.
In the tissue, which is undeniable proof that inhaled particles aren't just being coughed up or exhaled. They are accumulating deep within our respiratory system. And that's worrying, given how delicate lung tissue is. Then there's the really critical finding, the one that's got scientists particularly concerned. Microplastics have now been detected in human blood.
In our blood. Wow.
Yes, and that's huge because it means these particles aren't just staying in the gut or the lungs. They have the ability to cross biological barriers like the intestinal wall and actually enter the circulatory system.
And once they're in the blood,
they can go anywhere. They become systemic. They can be transported throughout the entire body, reaching organs and tissues far removed from where they first entered. We're talking a potential exposure for pretty much every part of us.
That's quite a leap from just passing through.
It really is, and it gets more concerning. A discovery with really significant potential implications across generations is their detection in the human placenta.
The placenta. But isn't that supposed to protect the fetus?
It is. It's designed to be a very effective filter, providing nutrients while blocking harmful substances. The fact that microplastics have been found there is deeply concerning. It suggests they can breach this vital barrier, potentially exposing the developing fetus directly.
So exposure could start even before we're born.
That's the implication, yes. It raises profound questions about developmental health and potential lifelong impacts, starting from the very earliest stages of life. And perhaps the most astonishing finding, the one that really pushes the boundaries, is the evidence suggesting that nanoparticles, those tiniest fragments, might even be able to cross the blood-brain barrier.
The blood-brain barrier, I thought that was incredibly selective, really hard to get through.
It is. It's a highly sophisticated defense mechanism, a network of specialized cells protecting the brain from harmful things in the bloodstream. If plastic nanoparticles can potentially breach that fundamental defense, well, the potential neurological consequences, the impact on brain health, are frankly quite alarming and a major focus of current research. We need to understand that interaction much, much better.
So let's connect the dots here. They're found in feces, lung tissue, blood, the placenta, potentially even crossing into the brain.
Exactly. If you put all that together, the big picture is undeniable. Microplastics aren't just passive visitors passing through. They're becoming integrated into our biological systems. They're undertaking a journey inside us, moving from entry points to vital organs, even into the most protected areas. This completely changes our understanding of human exposure and the potential health consequences down the line. It shifts it from a simple passage to active biological interaction and accumulation.
Okay, so they're inside us. They're circulating in our blood, accumulating in our lungs, potentially reaching our brains, even crossing the placenta. It's a truly unsettling picture, completely undermining that old passes right through idea. So the unavoidable, massive question that follows is, what are they actually doing to us? What are the health risks linked to this quiet, constant exposure, this ongoing biological presence?
That is absolutely the critical question, isn't it? And it's really important we frame this accurately, just as our source material does. Right now, establishing a direct causal link saying this specific amount of microplastic causes this specific disease in humans that's still under very active and complex investigation. We don't have all those definitive smoking guns yet for every condition. However, and this is the crucial part, the potential risks and the identified mechanisms of harm are a very serious and rapidly growing concern within the scientific and medical communities worldwide.
So it's about how they could be harming us based on what we know about biology.
Precisely. It's about understanding the plausible pathways for damage, pathways that are being robustly investigated. The alarm bells are ringing loud and clear, even if we're still mapping out all the exact connections. The core insight isn't that every exposure guarantees illness tomorrow. It's that the science has clearly identified how these particles could be silently, persistently undermining our health over time. It's like a low-level, constant biological stressor that over years or decades could contribute to a whole range of chronic health problems.
Think of it as a slow burn.
Okay, so what are some of those specific ways they might be causing harm? What mechanisms are scientists looking at?
Well, one major area of concern is chronic inflammation. Our immune system is designed to react to foreign objects. The constant presence of these tiny plastic particles, which the body recognizes as foreign invaders, can trigger a low-grade, persistent inflammatory response in the tissues where they accumulate.
Like the body's always slightly on alert. Exactly. Imagine your body constantly trying to fight off these microscopic irritants day in, day out. Over the long term, chronic inflammation is a well-known driver or contributor to a huge range of serious diseases, things like cardiovascular problems, some neurodegenerative conditions like Alzheimer's, certain autoimmune diseases, and even some types of cancer.
Right, so just their physical presence is potentially problematic.
Yes. Then there's oxidative stress. When our cells interact with these plastic particles, especially the smaller ones, it can disrupt the delicate balance between harmful molecules called free radicals, or reactive oxygen species, and the body's antioxidant defenses. An excess of these free radicals can damage vital parts of our cells: DNA, proteins, the cell membranes themselves. This process, oxidative stress, is like, well, biological rusting. It can impair how cells function, make them age faster, and again, contributes to the development of various diseases over time.
Okay, inflammation, oxidative stress. What else?
With nanoparticles, those really tiny ones, there's concern about direct cytotoxicity. That literally means toxic to cells. Because they're so small, they might be able to actually get inside individual cells. And once inside, they could physically disrupt normal processes, interfere with metabolism, block communication pathways within the cell, and potentially even trigger cell death. It's a very direct form of harm at the most fundamental level.
And is it just the plastic itself, the physical particle? Or is there more to it?
That's a crucial point and possibly one of the most worrying aspects. Chemical toxicity from leaching additives. This is huge. You see, it's often not just the base plastic polymer that's the issue, it's the cocktail of chemicals manufacturers add to the plastic to give it specific properties, flexibility, color, fire resistance, UV protection, you name it.
Additives, like what kind of things?
Our source specifically calls out examples like phthalates, which are used to make plastics flexible, and BPA, bisphenol A, used in some hard plastics and resins. There are many others too, flame retardants, stabilizers. The problem is, these chemicals aren't usually tightly bound to the plastic structure. They can leach out, especially once the plastic particles are inside the warm, moist environment of the body. They can seep into surrounding tissues and get into the bloodstream.
And what do those chemicals do?
Well, many of them are known endocrine disruptors. Phthalates and BPA are classic examples. Endocrine disruptors interfere with our hormone system, the system that controls growth, metabolism, mood, reproduction, just about everything.
They mess with our hormones.
They can mimic them, block them, or otherwise disrupt their normal function. This can lead to serious problems. Issues with reproductive health, like reduced fertility or developmental problems in offspring. They're also linked to an increased risk of certain hormone-related cancers, like breast or prostate cancer, and metabolic disorders like obesity and diabetes. So the chemicals leaching from the plastic could be just as, or even more, harmful than the plastic particle itself.
That's a whole other layer of complexity.
It is. And finally, there's the potential impact on our gut dysbiosis. Think of your gut microbiome, the trillions of bacteria and other microbes living in your digestive tract, as a complex, vital ecosystem. It's crucial for digestion, immune function, even mental health through the gut-brain axis.
Right. The gut microbiome is incredibly important.
Absolutely. Now imagine a constant stream of indigestible, potentially abrasive plastic particles passing through that delicate ecosystem. The evidence suggests they can physically alter the gut environment, change the balance of microbial species, favoring some, harming others. This disruption, this dysbiosis, is linked to a huge range of health issues, from inflammatory bowel disease to allergies, obesity, and even effects on mood and cognition.
So they could be messing with our gut bacteria too.
It appears so.
Yeah.
So when you put all these potential mechanisms together, chronic inflammation, oxidative stress, direct cell toxicity, leaching chemicals messing with hormones, disrupting the gut microbiome, it paints a worrying picture. It really raises this critical question about the long-term consequences.
Yeah.
What does decades of this quiet, constant exposure, this slow accumulation in biological irritation actually mean for our health over a lifetime? We're only just starting to scratch the surface. The full impact might not be known for years, which makes the problem incredibly urgent now. It's a massive area of ongoing research for a very good reason.
Okay, this is clearly a huge challenge. Immense, really, given how tied plastic is to everything we do. The scale feels overwhelming. But the source material doesn't just leave us there, right? It also points towards solutions. It sounds like it needs a really multifaceted approach, though, not just one fix. Absolutely, you're spot on. There's no single silver bullet for microplastics because the problem is so deeply embedded in our systems, production, consumption, waste. The solutions have to be just as systemic and multi-layered. We need action at every level, from the very top down to individual choices.
So let's start at the top. What needs to happen at the global governmental level?
Okay, on the big stage, a really key foundational step is getting a strong global UN treaty specifically targeting plastic pollution. Our source emphasizes this, and crucially, it needs teeth. It should ideally include legally binding targets for countries, targets to seriously reduce the production of new virgin plastic, targets to massively improve waste management infrastructure globally, and ultimately a clear goal to end the leakage of plastic into the environment, both on land and in the sea. So a coordinated global effort with real rules.
Exactly. A unified framework that holds everyone accountable, which we really lack right now. Alongside that, individual governments need to step up with direct actions. Introducing bans on the most problematic single-use plastics is a clear win.
Like bags, straws, cutlery.
Precisely. Things like single-use plastic bags, disposable tableware, cotton buds with plastic sticks, and crucially, cosmetics containing intentionally added microbeads, those tiny plastic spheres once common in face scrubs. These are often things with readily available alternatives, and banning them cuts off a significant source of pollution right at the start. Another really important policy tool is extended producer responsibility, or EPR.
EPR. How does that work?
Basically, it shifts the responsibility financially and logistically for dealing with a product's end-of-life waste away from taxpayers and local councils and puts it back onto the company that produced or sold the product in the first place.
So the maker pays for the recycling or disposal.
In essence, yes. If a company makes plastic bottles under EPR, they have a responsibility to ensure those bottles get collected and properly managed after use. It creates a powerful incentive for them to design products that are easier to recycle, use less problematic materials, and maybe even set up their own take-back schemes. It internalizes the cost of waste.
Okay, that makes sense. What else at the government level?
Infrastructure. This is absolutely critical. We urgently need massive investment in upgrading existing wastewater treatment plants and building new ones that are actually capable of capturing microplastics effectively.
Our current plants don't catch them.
Most conventional plants weren't designed to. They might catch some larger fragments, but tiny fibers and particles often pass right through. We need to implement more advanced treatment stages. Things like tertiary treatment, quaternary treatment, basically adding extra finer filtering steps, and technologies like membrane filtration using incredibly fine membranes, almost like microscopic sieves, that can physically block even very small particles, maybe even down to the nanoscale in some advanced systems.
So serious upgrades to water treatment.
Huge upgrades are needed globally. These high-level actions, the treaty, the bans, EPR, the infrastructure investment, they are the bedrock. They set the rules and build the systems needed for all other solutions to work effectively and to stop adding so much more plastic to the environment.
Right. So governments set the stage. But what about the companies actually making and using all this plastic? Industry must have a massive role to play, surely, especially since so much of modern business relies on cheap, often disposable plastic.
Oh, absolutely central. Industry's role is pivotal, and it demands nothing short of a fundamental paradigm shift in how they operate. They need to move decisively away from the old linear model, take resources, make something, use it briefly, then dispose of it towards a circular economy.
Circular economy.
Yeah.
Can you unpack that a bit?
Sure. In a circular economy, the goal is to keep materials circulating at their highest possible value for as long as possible. It's about designing out waste and pollution from the beginning, keeping products and materials in use through reuse, repair, refurbishment, and ultimately high-quality recycling so materials can genuinely be used again and again, minimizing the need for new virgin resources.
So it's about closing the loop.
Exactly, closing the loop. And for industry, this means, first off, a huge focus on innovation and product redesign. Companies need to start designing products for circularity. That means making goods that are durable, easy to repair, easy to disassemble, and made from materials that can be effectively recycled back into high-quality materials, not just downcycled into lower-grade stuff. It also means seriously tackling excessive packaging, all those layers of plastic wrap and containers that often serve little purpose beyond marketing, designing waste out.
And what about the materials themselves?
That's the second key area. Developing and scaling up alternative materials. We need genuinely biodegradable and compostable materials, ideally made from renewable resources, that can replace conventional plastics in certain applications, especially packaging. But, and our source stresses this caution, we need to be careful not to just swap one problem for another. Some so-called bioplastics only break down under very specific industrial composting conditions that aren't widely available, or they might contaminate conventional plastic recycling streams or have other environmental impacts.
So no greenwashing.
Precisely. We need robust science, transparency, and standards to ensure these alternatives are truly better overall. It's not simple. And thirdly, businesses absolutely must take more responsibility within their supply chains, especially regarding something called nurdles.
Nurdles, what are they?
Nurdles are tiny plastic pellets about the size of a lentil. They're the raw material, the building blocks for almost all plastic products. Billions and billions of them are produced and shipped around the world. The problem is they spill easily. During production, transport, handling, huge quantities leak into the environment, especially waterways. They're a major source of direct plastic pollution before they even become a product.
Wow, I hadn't really thought about that stage.
It's a massive, often overlooked issue. So companies throughout the plastic supply chain need much stricter procedures and better containment to prevent these nurdle spills. Operation Clean Sweep is an industry initiative aiming at this, but it needs wider adoption and enforcement. Overall, it requires a profound shift in corporate thinking, moving beyond just short-term profit to genuinely integrating environmental stewardship and long-term sustainability into their core business models and designs.
Okay, so we have policy changes, industry transformation. Are there also specific technological fixes that can help us? Tools to deal with the plastic already out there or stop it at specific points?
Yes, definitely. Technology offers some really practical tools that can act as important layers of defense, often providing more immediate ways to intercept plastics. One great example, which is becoming more accessible, is installing special filters on washing machines.
Filters for your washing machine.
Exactly. These filters are designed specifically to capture the synthetic microfibers, those tiny plastic threads from polyester, nylon, acrylic clothes that shed during every single wash cycle, millions of them per wash.
And the filter just catches them before they go down the drain.
That's the idea. By capturing them right at the source, in the home, these filters can dramatically reduce the amount of microfibers flowing into our sewage systems and eventually into rivers and oceans. It's a direct intervention that, if widely adopted, could have a really significant collective impact.
That sounds quite practical.
Yeah.
What else?
Another critical area is advancing and scaling up water purification technologies, not just for wastewater treatment plants, as we discussed, but also potentially for cleaning up rivers or coastal areas before the microplastics reach the open ocean. Once they're in the vastness of the ocean, they become incredibly dispersed and almost impossible to remove effectively. So technologies that can capture them in more concentrated areas like river mouths or industrial discharge points are really important. This might involve advanced filtration systems deployed on barges, or maybe technologies that use sound waves or electrical fields to clump particles together for easier removal. It's an active area of research and development.
Trying to catch them before they spread too far.
Exactly. And then there's research focused on the sources themselves. Our source highlights the importance of developing more durable materials, particularly for things we might not immediately think of as plastic pollution sources, like car tires and road surfaces. Yes, tires wear down as we drive, shedding huge quantities of tiny particles made of synthetic rubber and other chemicals. It's estimated to be a massive source of microplastic pollution globally. Likewise, the binders used in asphalt roads can wear down. So research into creating tires that last longer and shed fewer particles and developing more resilient road surface materials could tackle another major, currently poorly regulated source of microplastic pollution.
Right, addressing those less obvious pervasive sources.
Precisely. These technological solutions, from household filters to advanced materials and large-scale water cleaning systems, all play a part. When combined with policy and industry shifts, they offer practical ways to reduce the flow and impact of microplastics.
Okay, this is all making sense. We need the big systemic changes, government rules, industry transformation, better technology, absolutely vital. But the source material you said also really emphasizes the individual. What can you, our listener, actually do? It can feel a bit overwhelming, like individual actions don't matter against such a huge problem.
That's a very common feeling, but it's so important to push back against it. The source makes it crystal clear. The role of each individual is crucial and cannot be underestimated. Why? Because collective changes in behavior, millions of people making similar choices create enormous pressure. They signal to producers what consumers want. They drive demand for sustainable alternatives. They build political will for stronger policies. Your choices, multiplied, really do matter.
Okay, so how do we approach that? Is there a simple framework?
There is. Our source highlights the 5R principle as a really practical, actionable guide for everyday life. It's easy to remember. Refuse, reduce, reuse, recycle, and rot.
Okay, let's break those down. First, refuse.
Refuse means actively saying no to unnecessary plastic, especially single-use items that are often just handed to us out of habit or convenience. Think plastic shopping bags, bring your own reusable one. Disposable coffee cups with plastic lids, use a travel mug. Plastic straws, disposable cutlery, excessive packaging on fruit and veg. Just refuse it where possible. Be prepared with your own alternatives. It directly stops that plastic from ever being created or entering the waste stream.
Makes sense. Second, reduce.
Reduce means cutting down your overall consumption of goods that come heavily packaged in plastic. This might involve buying food in bulk using your own containers, choosing products in glass or cardboard instead of plastic where you have a choice, consciously selecting items with minimal packaging. It's about being mindful before you buy, aiming to bring less plastic into your home in the first place.
Okay. Third, reuse.
Reuse is about extending the life of items as much as possible, fighting against that throwaway culture. It's simple but powerful. Use glass jars for storage instead of buying new plastic tubs. Carry a reusable water bottle everywhere instead of buying bottled water. Always keep cloth shopping bags handy. Use real plates and cutlery instead of disposables. It's about valuing durability over disposability.
Got it. Fourth, recycle.
Recycle the plastic that you simply couldn't refuse, reduce, or reuse. It's an important step, but, and this is a really crucial nuance the source makes, recycling is not the perfect solution. It should be seen as the last resort in the plastic hierarchy, not the first.
Why the last resort?
Because recycling processes consume energy, they often result in downcycling, where the plastic quality degrades, meaning it can't be recycled indefinitely, and frankly, global recycling systems are often inefficient and overwhelmed. Contamination is a huge issue too. Putting the wrong things in the bin can ruin a whole batch. So it's vital to learn your local recycling rules very carefully and follow them diligently. But always try to learn. Refuse, reduce, and reuse first.
Right. Recycle properly, but only what you absolutely have to. And the last are rot.
Rot refers to composting your organic waste food scraps, garden clippings. Why does this help with plastic? Well, it dramatically reduces the total amount of garbage you send to landfill or incineration. Less garbage often means fewer plastic bin liners needed, and it eases the burden on municipal waste systems, which are often struggling. Plus, compost is great for your garden. It closes another waste loop in your home.
The 5 R's, refuse, reduce, recycle, rot. That's a clear framework.
Yeah.
Are there other specific tips?
Definitely. A few other impactful things you can do. When buying clothes, try to choose natural fabrics, cotton, linen, wool, hemp, tencel over synthetics like polyester, nylon, and acrylic whenever possible. Synthetics are a major source of microfiber pollution when worn and washed. Consider using a drinking water filter at home, whether it's a simple pitcher filter, one that fits on your tap, or an under-sink system. Given that microplastics are being found in tap water, filtering it can reduce your direct consumption. Use your power as a consumer. Actively support companies that demonstrate genuine commitment to sustainability, use minimal or eco-friendly packaging, and are transparent about their practices. Your money is a vote. And maybe one of the most powerful things, spread the word. Talk to your friends, family, colleagues about this issue. Share what you've learned. Raising awareness is critical for building that collective momentum for change. Education turns individual concern into powerful collective action.
So wrapping this all up, what does it mean? We've gone deep into microplastics, how they sneak into our bodies, the potential health worries, the huge layered effort needed to even begin tackling it.
Yeah.
It's clearly much more than just litter on a beach, isn't it? What we've really uncovered here is that this isn't just an environmental issue. It's fundamentally a public health problem. It's an economic challenge. And you could even say it's an ethical one. It feels like the quiet, pervasive legacy our plastic age is leaving behind, literally weaving itself into the fabric of life on Earth.
That's a powerful way to put it. And if we connect this to the bigger picture, the really stark reality is we can't just clean up the microplastics already out there. Not effectively. They're too small, too widely spread, too deeply mixed into everything: soil, water, air, us. So the fight against them, it's not a quick campaign. It's not a sprint. It's definitely a marathon. It requires ongoing, sustained effort for years, likely decades. The real solution, the only lasting one, has to lie in fundamentally rethinking our entire relationship with plastic itself.
A radical rethinking.
Exactly. And that raises this really important question for all of us as societies, as a global community. Are we truly ready and willing to shift, to move away from this ingrained culture of disposability where convenience often wins out, towards a culture that genuinely values responsibility, durability, and stewardship? Because the ultimate goal here, the only strategy that really works long-term, is to turn off the tap. We have to stop the relentless flow of new plastic waste into the environment in the first place, rather than just endlessly trying to manage the mess after it's already escaped.
Turning the tap.
Turn off the tap. And that demands everything working together. Governments setting strong, binding rules, corporations innovating and redesigning for circularity, scientists continuing the vital research, and crucially, every single one of us making conscious choices, demanding change, and playing our part every single day.
The threat is invisible, much of the time, but it is undeniably real. And to ignore it, to just carry on as we are, feels like accepting a future where plastic becomes a permanent fixture, not just in our oceans and our soil, but inside our own bodies, inside our children. The choice to change that future is ours, and the time to act is now. Thank you for joining us on this deep dive.